It's now the turn of Stefan Plaettner, Research Associate for Highly Realistic Driving Simulators at Technical University of Dresden. His presentation will cover the systematic evaluation process that led the team to the selection of a realistic simulation software fully based on VI-grade solutions to ensure the full functionality of their driving simulator.
Driving simulators exist due to the variety of use cases and different designs, which leads to essential variations of the used hardware and software for simulation. Because every simulator system is somehow unique, there's enough room for making mistakes in the conception and the design. With this presentation, I want to show you our development approach, especially from the simulation software perspective. My name is Stefan Plaettner. I'm a research associate at the chair of automobile engineering here at the University of Technology in Dresden. And I'm responsible for the simulation environment of our new dynamic driving simulator. Our research institution started the development project, the highly immersive driving simulator, in 2019, funded by the German government. The aim of our project is the feasibility of a new wheel-based driving simulator concept in cooperation with our partner, the AMST Systemtechnik. The commissioning of the whole system will take place during 2023. And afterwards, we will then conduct research and industry projects with a high flexibility regarding oncoming use cases of the simulator. This I will show you later on. On the right side of the slide, you can see the spec sheet of the simulator. One aspect to highlight here is the unlimited motion space due to the tire-based platform, which I want to give you an insight in the next slide. Our novel approach is a tire-based motion system. Starting at the top, we have the visualization dome of the MockUp, which is quite common. And below there is a hexapod and a yaw bearing. And hexapod is for the short, high dynamic movements, and the yaw bearing allows an infinite rotation. The basis of the system is the motion platform for the longer and low dynamic movements, where also the battery is located. In total, we have 4 wheel modules, each with its propulsion system and steering system. And each wheel module is linked to the motion platform by a double wishbone suspension. To give you an idea of the dimensions of the whole system, the overall size is nearly a cube of 5 meters, so quite big. And the development phase and implementation phase of our dynamic simulator will last until 2023, as I already mentioned. And our idea was to build up a static simulator for the pre-development in parallel. So the static sim is now a development tool, mainly for the simulation environment. Our aim is here to get in touch with different software solutions, see the chances and also risks of different frameworks, and furthermore build up experience and test the workflow for subject studies and build up some lessons learned, let's say. And to sum up, we wanted to anticipate common challenges like software interfaces, the simulation performance regarding frames per second and the latencies that occur, as well as trade-off between the quality and the computational performance for the static and dynamic environment model. And hopefully we can then ensure an optimal commissioning of this framework we aiming for our dynamic simulator. And also after 2023, when our research projects and industry projects will take place, the static simulator will be useful as a preparation tool. So when the dynamic simulator is ready for the test person studies, we can later set up the whole environment for the environment model for the subject study at our static sim. So prepare the virtual world, test the accuracy of scenarios and so on. And if this all is finished, then we can transfer the whole models and configuration files to our dynamic simulator to conduct the actual study. And the clear aim is here to save some money because of the higher operating costs of the dynamic simulator, as well as saving some time. So because of the lower complexity of the static simulator, maybe a future project could look like 3 months of preparation at the static simulator, and then only 3 weeks of conducting the real study at the dynamic simulator. But the prerequisite for doing this process is that we have the same software architecture on both systems to ensure the transferability, and there's also some modularity needed. A first initial question in the development process of the driving simulator was how it would be possible to systematically evaluate or identify which simulation software solution fits best to our simulator specifics. And we came up with the following approach. So at the top, you have the common software modules, beginning with the traffic environment, so the static and dynamic world around you, and the vehicle dynamics module, so the ego vehicle dynamics that is also responsible for the motion control of the dynamic system of the simulator. Then we have the visualization and acoustics as the representation of the virtual world, and also the haptics software. And our evaluation process is split up into 2 parts. On the left hand, we have the offline evaluation, we called it. This means we conduct the objective software performance parameters. So this has nothing to do with subject studies. It's more the economic aspects, like the costs of the software, but also the technical aspects, like the functional scope, what abilities has the software and which interfaces to other software solutions. And on the other hand, we have the online evaluation. Here we really wanted to conduct studies and gain the subjective perception of our test persons. So to analyze the key performance indicators of the driver behavior, there are a quite variety of parameters we can think of here. And in the end, our analysis results may later lead to a quantifiable influence of the used simulation software to the driving simulator validity. So it's clear that there is a reproducible, mainly standardized test procedure needed at the online evaluation in order to ensure the comparability between the different software solutions. The test procedure is not yet sufficiently substantiated, but we already tested some software solutions offline, made our own experience, and but only a few software solutions could be tested online in test person studies so far, mainly out of other research projects. And this also underlines the need for a more standardized evaluation process we are currently working at. And furthermore, there is a boundary condition for the configuration of the simulation framework. So the traffic and environment module is most often the central part of the simulation environment software. And this defines compatible modules, for example, for the visualization. So not every combination one might think of is technically feasible, as you already know. Anyhow, our choice for the simulation environment, based upon the experiences we could make until now, led to the VI Drive Sim framework, including VI Car Real Time and also VI World Sim, running on a concurrent real-time machine. And the virtual replication of the scene convinces by being based upon the powerful Unreal Engine. And this easily allows creating static environments with Roadrunner, which later can be played by setting up scenarios and surrounding traffic in VR WorldSim. And to give you an insight, look here to our software architecture. I sketched up the whole system, and you can see the concurrent real-time machine as the central part with the VI DriveSim framework and also the control in the middle, and the link to our motion filter for the dynamics. On the left side, you have the image generator for the projection system, as well as the mirrors for the side and rear mirrors. And on the other hand, you have we have the simulation PC dedicated for the traffic master as well as the acoustics. And then we have a separate PC for the eye tracking, data synchronization, data logging, and also for third-party tools. Yeah, and the application of this structure onto our dynamic simulator is currently underway. Now I want to point out some potential use cases of the driving simulator and show you which essential role the regarding software module will play here. The first potential use case of our driving simulator will be the self-motion perception. Here, the ego vehicle model is key for sophisticated motion control for dynamics. The highest quality of the real-time vehicle model is needed here. And the driving dynamics model itself is a central domain of our chair of automobile engineering. We can ensure the highest quality of parameterization process for the systems and components of the vehicle model, which is possible through our multiple test benches we have here in our vehicle testing facility at the Dresden Institute of Automobile Engineering. Yeah, here we have the chance to measure a broad variety of parameters, and we also have the chance to validate the parameterized vehicle models with in-house real driving tests. We call this whole system the parameterization pipeline. A second use case for our driving simulator will be the safety assessment of advanced driver assistance systems. So especially for HMI concepts, which will definitely play an essential role regarding highly automated or even autonomous driving functions. Here we can make use of our freely programmable displays within our complex MockUp that is based on a prototype HAN. And you can see there are several functionalities that we will use for scenario-based testing, like our fully customized steering wheel with a 360 degrees light bar and also a hands-on detection function. And furthermore, we have head and eye tracking system. So for this setup in total, the signaling and interfaces through the entire VI framework is crucial. And the next and last potential use case I want to show here is the simulator validation itself. So to understand the connection between the influencing parameters of the simulator hardware and software on the one hand, and the corresponding indicators of the driving behavior validity on the other side is very crucial. So, for example, the impact of the choice of a visualization software will have an impact on the results of the subject studies in the simulator. And we are currently identifying which tests are needed to make this impact measurable. And ideally, we can then in the end present a simulator validity evaluation tool, which allows everyone to classify its driving simulator, for instance, regarding the used visualization software. And with this, I want to end my presentation, and thank you very much for your attention. If you have any questions, please feel free to send me an email. Thank you very much.